Hello and welcome. My name is Flower Girls, and this is going to be a series looking at the Max user guide. I'm going to take you through each tutorial in the user guide and go through the examples that the Max team built to help explain the user guide for you. So here we are in Max. This is the very first tutorial. But before we jump in, I'm going to show you how to find this user guide so you may follow along yourself if you wish. So you go to help up here in Max, you go down to user guide, it will open the user guide here, then you go down, you see tutorials, and this series is going to focus on signal processing. So you press signal processing, it will take you to a website. If you want to follow along with the examples that I used in this tutorial series, then you can download this series assets. And I recommend going through these 4 examples, which I'm not going to go over. I'm going to start today with the basics tutorial 1. So from the basics tutorial, there are many tutorials up until the very end with these series assets. So that is what I'm going to focus on. Here you can see which patcher the tutorial references. In this case, it's 01m_testtone.maxpat. So I have it open here. This is what the patcher looks like. So MSP objects are pretty much like Max objects. MSP objects are for processing digital audio, i.e. sound, to be played by your computer. MSP objects look like Max objects, have inlets and outlets just like Max objects, and are connected together with patch cords, just like Max objects. They are created the same way as Max objects. To start this tutorial series, ideally you should do the working with Max tutorials first. If you press N, you can make a new object, and there are objects such as bang, where you press B and you make bang, or message if you press M, and these are Max's Max objects because they just use logic and numbers, they don't use audio. So what makes MSP objects different? A patcher containing interconnected MSP objects works a little differently from a patcher containing standard Max objects. One way to think of the difference is just to think of MSP objects as working much faster than ordinary Max objects. Since MSP objects need to produce enough numbers to generate a high-fidelity audio signal, commonly 44,100 numbers per second, i.e. 44K, they must work faster than the scheduler used by standard Max objects, which typically runs around 1,000 times per second. So any of these objects, such as the normal line or bang messages, we can see some here as well. They run at 1,000 times a second. That's what it says here. That's what the usual scheduler used for standard Max objects works like. It's 1,000 times per second, but that's not enough to generate high fidelity audio signal, which requires 44,100 numbers per second. And you can find out why we need this specific number in the How Digital Audio Works tutorial. Here's another helpful way to think of the difference. Think of a patch of MSP objects not as a program in which events occur at specific instance, as in a standard Max patch, but rather a description of an instrument design, a synthesizer, a sampler, or effect processor. It's like a mathematical formula, with each object constantly providing numerical values to the objects connected to its outlet. At any given instant in time, this formula has a result, which is the instantaneous amplitude of the audio signal. This is why we frequently refer to an ensemble of interconnected MSP objects as a signal network. This is the difference between something like this, which I found using the help and examples section under effects, which is a signal path, a signal network, and something which just uses max objects, which are logic objects. This is not an instance of an event. This is a continuous flow of signal. So once it's turned on, signal will continuously flow in this patcher. So whereas a patch made up of standard max objects sits idle and does nothing until something occurs, a mouse click, an incoming MIDI message, the clock firing on a metro object, etc., causing one object to send a message to another object, a signal network of MSP objects, by contrast, is always active, from the time it's turned on to the time it's turned off. This means that if you leave a patcher like this on, so if we turn this on, start, and then go to do something else in our computer, this is going to eat more CPU than a patcher which just uses logic objects such as these, because it's consistently running. And it says why here. All of its objects are constantly communicating to calculate the appropriate amplitude for the sound at that instant, and that instant is 44,100 instances per second, so it's a very small instance. This is why in Max these objects look a little different. So the names of MSP objects end with the tilde character. Any of these objects are just called line, or just the name of the object and nothing else to it, such as append. Just append. But if you want to deal with max signal processing, which is what MSP stands for, then it will be cycle and then tilde, which is next to the shift key. This just serves as an indicator to help you distinguish MSP objects from other max objects. The patch cords between MSP objects have stripes. This helps you distinguish the MSP signal network from the rest of the max patch. So if you look over here in the example, you can see this orange cord. It looks a bit like a tiger. Let me show you this one here. It's black and yellow, like a tiger's tail, as opposed to just the grey one that comes from these message objects, which means that there's just data flowing through it, numbers, and not signal. And it says so here in the tutorial as well. MSP objects are connected by striped patch cords. Now take a look at the tutorial patcher. You'll see that we have 6 items of our patcher's canvas. This is a bit outdated actually. It doesn't have the comment box, but it does have 2 message boxes labeled start and stop that we can see here. Start and stop. If you ever are unsure of what object you're looking at, you can always look at the bottom part of the Mac screen here. I'm here, and it says message, send any message. If I go over line, it says generate timed ramp, or here plus add 2 numbers, output the result. Also, alternatively, you can press option and click, and it will show you what object it is and give you a quick explanation of what it does, including this tutorial. We have a cycle tilde object. Now, as we've just learned, anything that has a tilde in it is an audio object. It's an MSP object, not a max standard object. So as we can see here in the side panel of Max, if we go to objects, so we have the Max objects and then we have the MSP objects. These are 2 different groups of objects. Every MSP object has a tilde sign behind it, as we can see here. So we have found the cycle object, which if you go to the list here, it should be under C. Yep, there we go, cycle. But you can also just press N for new, and then type cycle and it shows up in this list. You can go with the arrow key and select cycle, and there we go, we have a cycle object. DAC tilde object, what does that mean? Digital to analog converter. And something that looks suspiciously like a slider but is actually a gain tilde object. This is the gain tilde object. Again, you can see down here, it says gain tilde, gain control. You can press option and you will see the tutorial again. Let's look at these objects in turn, starting with the DAC tilde at the bottom of the patcher and returning from there to the top of the chain. This is the DAC, and that's what it stands for. You can press option click and see what it looks like. Audio output and on/off. The DAC tilde digital to analog converter object sends its signal inputs to audio hardware. Double click on a DAC tilde to open the audio status window to configure audio settings and hardware. So if we double click, it takes us right to audio in the settings, which we can also get to, for example, if we press command and comma, it will take us there as well, just settings in general. The digital to analog converter, DAC for short, is the part of your computer that translates the stream of discrete numbers in a digital audio signal into a continuous fluctuating voltage, which will drive your loudspeaker. So this object turns what is just still numbers, in this instance, into you hearing the sound through your headphones or speakers. Once you have calculated a digital signal to make a computer-generated sound, you must send the numbers to the DAC. So MSP has an object called DAC tilde. This object is generally the terminal object in any signal network and is required for any signals generated by MSP to make it out of your computer as sound. The DAC object receives the signals you wish to hear in its inlets. It can have as many inlets as there are available channels of audio playback on your computer, though it defaults to a stereo configuration talking to the first two channels of your audio hardware. This is why there are two inlets on the DAC tilde in your patcher. If you are using more elaborate audio output hardware, you can type in arguments to specify other audio channels. So yeah, so if you do this, then you will see the number of outputs here. These are the arguments that you can add to an object, and then attributes are different, but this object doesn't have any attributes for channel. I don't know. Doesn't seem to. Okay. Important. DAC tilde must be receiving a signal of non-zero amplitude in order for you to hear anything. DAC tilde expects to receive signal values in the range -1.0 to 1.0. Numbers that exceed that range will cause distortion when the sound is played. Oops. So the cycle tilde object here is sending amplitude information from -1 to 1 because it's a cosine wave. But if it was greater than -1 and 1, then we would have a problem with the DAC. That's what it's saying. The best way to produce a periodic waveform is with cycle tilde. This object uses the technique known as wavetable synthesis. It reads through a list of 512 values at a specified rate, looping back to the beginning of the list when it reaches the end. This simulates a periodically repeating waveform. And you can see here that it's a cosine wave, which you can see here it starts at 1. A sine wave would start at 0, then go to 1, then -1, and finish at 0. You can direct cycle tilde to read from a list of values that you supply in the form of an audio file, or if you don't supply one, it will read through its own table, which represents a cycle of a cosine wave with an amplitude of 1. We'll show you how to supply your own waveform in a later tutorial. For now, we'll use the cosine wave. So here are 512 numbers. You can see here, including the 0, it's 0 to 511, so 512 samples, essentially, or screenshots of the amplitude, creating a cosine wave. The cycle tilde object receives a frequency value in hertz in its left inlet, and it determines on its own how fast it should read through the list in order to send out a signal with the desired frequency. I'm going to skip along this technical detail. The cycle tilde object has a default frequency of 0 Hz, so in order to hear the signal, we need to supply an audible frequency value. This can be done with a number argument, as in the example patch. So what they have done in this example is give an argument. So if I delete the 1000, you can see the arguments that come up. Frequency is the first one, so you type in any frequency you like. You can do 10,000, and if I press start, it'll be an awfully high sound, or maybe we can do 50. Very low sound. Let's go back to the 1000. So this can be done using that method, or by sending a number in the left inlet. So in the left inlet of the cycle tilde object, you can hover above it here and see that it accepts a frequency here, or by connecting another MSP object to the left inlet. If we listen to the output of the signal with its frequency set to in an audible range, there's a typo here, we should hear a sine wave, the purest in terms of spectrum sound that we can make. So we can listen again. It's an awful sound, not particularly interesting, but it will get more interesting in the later tutorials. So we've looked at the DAC, we've looked at the cycle tilde. Now the one remaining DSP object is this one. These two are, as I've said before, max objects. They don't deal with sound, which is why their cables are grey. If we were to directly connect our cycle tilde object to a DAC object and start the audio, we could easily damage our speakers, or more importantly, our ears. MSP objects that generate audio, such as cycle tilde, generally do so at a normalized dynamic range of -1 to 1. We can see that up here in this graph. It goes from 1 to 0, -1 to 0 to 1. To avoid these dangers, it's important to have an object in between to control the amplitude of the signal going to our speakers. The gain slider performs just such a function. So this is this object here. We can again open its reference by clicking Option and left click. Here we see gain control, gain control. Gain tilde is a slider that scales signals and can also make a smooth transition as you move from one value of the slider to the next. We can also find the gain if we press the plus here, go to audio, and it's the third object. And then you just drag it and you've got the gain. Or you can also just type in gain with the tilde and you will see the object. The gain tilde slider multiplies its incoming signal by a factor based on the position of the slider, which for all but the uppermost reaches of the object is a number less than 1. As a result, the gain tilde object almost always attenuates, which means turns down the volume of what comes in. The gain tilde object is in several ways a graphical version of a multiplied tilde object, which we'll look at in a later tutorial. So that's another object you can use for attenuating signal. Looks like that, but this is, as the tutorial says, a more graphical version. It's easier to see how much of the signal is coming through. Starting and stopping signal processing. We've looked at all three of these, and now all that's left is these two objects. I'm going to delete all these and close the inspector. The MSP audio network is off when Max boots up. It can be turned on with the on/off icon in the lower right corner of any window that contains MSP objects. So this one here. If it turns blue, then it's on, and if it's orange, which in this case it's not, it means it's technically on, but it's not producing sound. You might have to check your settings, that sort of thing. There is a slider just above this button that controls the levels of the window in the output mix. So this is the slider. When the window is open, this slider is at the unity gain point and can be used to balance the mix, but you should keep in mind that reducing the level with this slider may mask distortion that is caused by excessive levels within the patch. So just always keep an eye out on the patch itself and the sliders here, instead of always going to this master slider, similar to when producing with an Ableton. So, audio processing can also be controlled programmatically. The DAC tilde object is one of 5 MSP objects, along with ADC tilde, which means audio to digital converter. Their graphical cousins Easy ADC tilde and Easy DAC tilde, and AD status that can turn on and off the MSP audio network from within your patcher. Let's have a look. I'm fighting my mic here. Apart from DAC, there is also ADC tilde, which looks the same. There is Easy DAC, which is more graphical, as we can see here. And then when you press this, you can see it turns on. There is Easy ADC, which looks like a microphone, because it's, if you think about it, ADC, it's an audio to digital converter. So you're recording something with a microphone and turning it into digital information. So it's the opposite of taking digital information and moving it into the speaker world. It is very common to provide the start message with a load mess object so that audio begins as soon as the patch is opened. Essentially, it creates a bang when this patcher is opened. So you would see this bang, and then if you connect it to this start message, then it would start the audio automatically when this patch is opened. You could also give this slider a value of 35, and then when the patcher starts, it will be at this volume. Important, sending start or stop to any DAC or audio to digital converter object enables or disables processing for all open signal networks in all currently open Max patches. Very important, yeah, so all of these will be affected by anything you do here with these kinds of objects. Now, listening to the test tone, we finally made it. This tutorial is very boring, but it's the first one. We have to get through this one to get to the more exciting ones down the line. Already the second one is much more complex and much more interesting. You'll see. The first time you start up Max, it will try to use your computer's default sound card and driver. So Core Audio on Macintosh, and MME on Windows. If you have the audio output of your computer connected to headphones or an amplifier, you should hear the output of MSP through it. Similar to live, it's default, so in my case, I've connected it to Scarlett, which is my sound card, but by default it would be MacBook Pro speakers. So that's just pretty basic. It's just helping you get sound from this patcher. In order to get MSP up and running properly, we recommend that you start the tutorials using your computer's built-in sound hardware. If you want to use an external audio interface or sound card, please refer to the audio input and output chapters. I'm using a sound card. It's not that complicated. Essentially, all I've done to change this patcher is move this black and yellow cable to this right channel. So I've made another cable. Let me delete that one because it was just on the left channel, which is fine if you're using laptop speakers, but on headphones it's rather annoying. So I just made another tiger tail little cable here, and now it's both left and right. Troubleshooting. If you don't hear any sound coming from your computer when you start the DAC tilde in this example and turn up the gain tilde slider, check the level setting on your amplifier or mixer and check all your audio connections. Check that the sound output isn't currently muted. You can also check the sound preferences on your Macintosh. This is something I've done myself as well. And on Windows, the sound output level is set using the sound and audio devices setup. If you're still not hearing anything, choose audio status from the options menu and verify that a valid drive and output are chosen. Another typo are chosen in the pop-up menus. If one isn't, choose it. We've reached the summary. A signal network of connected MSP objects describes an audio instrument. The digital to analog converter of the instrument is represented by the DAC tilde object. DAC tilde must be receiving a signal of non-zero amplitude in the range of minus 1.0 to 1.0. These are float numbers, not integers. A float means it has a dot, so 1.0, 1.0. In order for you to hear anything, the cycle tilde object is a wavetable oscillator which reads cyclically through a list of 512 amplitude values. So remember, that's the screenshots of each of these values essentially, at a rate determined by the supplied frequency value. Signal processing is turned on and off with a button in the patcher window or by sending a start or stop message to any DAC or ADC object. Because sending a start message to a DAC tilde turns on audio in all open max patches that contain MSP objects, when going through these tutorials, just keep one open at a time. Close the patcher window before proceeding to the next chapter. Yeah, so just keep one of these open. That's what I'm going to do. That's the end of this tutorial. I hope it makes sense. Essentially, when you press this as well, it does seem to turn it on. So the reason why it was turning on and off when I changed the gain slider value was because there was this cable to here. I don't know why that was here, but I've deleted it and now it works as it should. So stop. If I change it, there's no sound. Start, there's going to be sound. If we look at this process again, the cycle tilde object is it's a wavetable oscillator. It's going through a period of 1 to -1, as we can see here. It's with the tiger stripe, it goes down to the slider here. This is a gain tilde object, and this controls, with some fancy math behind it in a smooth way, this controls the amplitude of the sound. After the gain slider, the left input here is the scaled output from the cycle tilde, so 2 tiger stripes go down to the digital to audio converter, which converts the digital numbers generated by the cycle tilde object into voltage to my speakers, my headphones, whatever you use. And that's the whole patch. It's a very simple patch, and the next tutorial is going to be much more exciting. So that's the end of the video. I hope you found it useful. I know it's very dry, but the next tutorials are going to be much more interesting. This is sort of a good way to test that Max is working at all for you. And yeah, it's a start to the exciting world of digital signal processing. So I'll see you in the next one.